Okay guys, thank you for coming here. We're going to go over the extra practice, which was on page 161. I gave you 17, 19, 21, 23, and 25. If you did it, here's a look at the answers. Number 17 is 400, number 19 is 300, number 1 is 24 cars. Those are word problems, so you have to include what the number refers to. Number 23 is 300 students, number 25 is 240 ounces. Alright, let's get started. Number 17. Okay, read directions first. Use double number lines to find the missing number. Okay, we're drawing two lines. A number line and a percent line. The number line always starts at 0. The percent line starts at 0%. And it ends at 100%, the percent line that is. Again, we're talking about one whole, trying to find the whole, right? So if you have the whole thing, if you tienes un entero, you have the whole thing, that's 1. So from 0 to 100%, that's all you can have about 1. Now, the whole number, it can be anything from 0 to whatever you want, infinity. Well, that's more a concept. Anyways, we're talking about a number. We don't know what it is, though, but we do know what part of that number is. How do we know? Because it says, the problem says 240, I'll write the problem down, 240 is 60% of what number? We don't know. Okay, look at the percent line. We do know the percent, 60%. Okay, that's less than 1. We only have part of it, right? We only have this much. And with that 60%, we know we have 240 of it, 240 whatever it is we're talking about. Okay, now here's the part we have to do a little thinking. We have to break up this percent bar. Why do I say that? Because I can go from 0 to 60, that'll be plus 60. But if I add 60 again, it goes to 120. That's more than what I have. I only have 100%. I only have 1 of this thing. So it's not 60. You have to skip or cut the bar, the line, into groups of something smaller than 60, hopefully. Okay, now, I notice it ends in a 0. I can do groups of 10, 10, 20, 30, 40, 50, 60. But that's too many divisions. Okay, there's nothing wrong with that, but it's just more work for me, and I try to do less work if I can. So I do a little thinking first. Okay, I can break this up into groups of 20, I think. 20, 40, 60. I mean, again, you know, I write it down. If I make a mistake, I can always erase it. 20%, 40%, 60%, 80%, 100. Okay, it looks like if I break this up into groups of 20, 20%, 20%, 20%, it works out evenly. I have 5 equal parts. 2, 3, 4, 5. Well, that means I'll have to do the same thing here. 1, 2, 3, 4, 5. Now, granted, the parts should all be the same. I know it doesn't look the same here. It's a quick sketch. I didn't pull out a ruler and measure exactly. But you get the idea. Anyways, from 0 to 240, I have 3 parts. 1, 2, 3. Now, I know all the parts have to be equal. So I have 240. I'm going to break it up into 3 parts. How much is in each part? Well, because I know my times tables, I know that I can make 8 groups out of 3, right? Yeah, to get 240. Well, 8 groups out of 3 you get 24, but if I had a 10, it's 210. And I don't know why I wrote 240 again. I'm not thinking straight. To be honest, a bit of a headache. So there it is, 80, yay. All right, so 80 plus 80 plus 80. Hey, it works out, perfect. So 80 plus 80 is 160, plus 80 is 240. And all I'm doing really is just looking at the first digit. 8 plus 8 is 16, plus 8 is 24, plus 8 is 32. And I add a 0 because we're talking about, you know, multiples. It's not just 8, it's 80, right? And again, plus 80. And then plus 80 again. That means our whole is 400. Okay. So let's look at this again, just make sure. 240 is 60% of this bigger number. So we only want part. 240 is part of this, but the whole is 400. Okay, on 19. Write a percent proportion and solve each problem. Okay, a percent proportion, we're going to have two ratios. We have to understand the parts and the whole. And we're going to have our percent ratio over here. 100 as a denominator because it's per 100, right? Percent per 100. All right. The problem states 270 is 90% of, and again, I'm just going to shortcut it, of the number. We don't know the number. Okay. Please don't confuse the numbers. 270 is the whole number. It goes with the whole number ratio, or just the number ratio. This is the percent ratio. How do I know? Because it has the percent symbol. So this is going to go right there. Now, is it a part or is it a whole? Also, don't confuse that. 270. I'm going to say it's a part. How do I know that? Where's my proof? Well, 270 is 90%, right? They're equal, equivalent. Again, they go along with each other. Of what number? So that's indicating we have a bigger number. That's not 270. Okay, 270 is less. It goes with 90%, and 90% is less than 100, which means 90% is less than 1. If this is less than 1, then that's less than 1. I want to kind of a little faster, but here we go. I'm going to rewrite it. 270 is 90% of what number? Now, again, you can simplify this right now. You can simplify this to 9/10, but always look before you start acting, before you attack the math. I have groups of 90, and I know my times tables. I know I can make 3 groups of 9 to get 27, right? That means I can make groups of 90 to get 270. I'm scaling up this way, okay? And we've done previous homework. You can switch the order around if it makes you feel better. The percent fraction doesn't have to go, percent ratio doesn't have to go first. Ratio can go second. However, the order doesn't matter just as long as you're consistent. All right, 100 times 3, that's 300. So 270 is part of 300, right? That should make sense. 270 is part of 300. How much of a part of it? 90%. See, there's this whole connection. All right, 21. It's a word problem. The drama club held a car wash on Saturday and Sunday. They washed a total of 60 cars. If they washed 40% of the cars on Sunday, how many cars did they wash on Sunday? All right, before you attack anything, draw a little quick visual. We're talking about 2 days, Saturday, Sunday. Again, you don't have to draw a picture like this. You can draw whatever works for you, but the idea is get the ideas down first. Saturday. And you've seen me draw cars before. They're not very carish, but again, I'm not creating your artistic ability, and this isn't for me. The drawings are not for me to see that, oh, you're an artist or not. I'm not going to judge on that. That's even worse. I'm judging myself. That's okay. All right. On both days, if you include both days, there were 60 cars washed. 60 cars washed. Okay? So we know that. They did 40% of the cars on Sunday. Well, even though it doesn't say it, that means by definition, if this whole thing is 100%, right? I think they glitched right now. If we know they did 60 cars on both days, and 40% was on Sunday, that means Saturday they had to do 60%. How do we know that? Because when you do everything, it's 100%. So 60 plus 40 is 100, and there we go. All right, we can do 2 number lines, or we can do percent proportions. I like that instead. Again, here we go. 40% is right there. 100 is right there. 60 cars is the total, right? And what did I just do? You see the mistake I just made? This way it's good to label it. Part, whole. We all make mistakes. All right, the total is 60. We don't know how many cars they cleaned on Sunday. Okay, let me write it a little neater. So we have so many cars that they cleaned on Sunday, which is what we don't know. But we know their total is 60 cars. 40% was what was done on that day. 100% was include both days. Okay. You could simplify this. Again, keep this in mind. Never forget this. When all else fails when dealing with fractions, you can't see a connection. I mean, I can't scale up from 60 to 100. I can't scale down from 100 to 60. Simplify. You always have that option. Simplify and see what you get. By now you should know that 40 and 100, you can divide by a factor of 20. We've done this so many times already. 40 divided by 20 is 2. 100 divided by 20 is 5. And we still have this. Okay. You should be able to see that you can scale up from 5 to 60 by a factor of 12. That means you do the same thing here. And 12 times 2 is 24. But it's not just 24. Okay. On tomorrow's quiz, you're going to have 2 boxes or 2 places to response. The box next to it is for the noun. I'll have a sentence that goes with it. You'll see it. Or on Friday. Tomorrow's Thursday. 24 cars. Okay. That's part of the answer. 24 cars. Okay, 23. According to the school survey, 12% of the students at Rockwood Junior High School, did I say word? Rockwood Junior High School speak Spanish. There are 36 students at the school who speak Spanish. I know I said the word wrong. How many students are surveyed? I'm going to say it again just because. According to the school survey, 12% of the students at Rockwood Junior High School speak Spanish. There are 36 students at the school who speak Spanish. How many students were surveyed? All right, again, just a little picture just to keep me going, just so you know what I'm talking about. Little windows. Rockwood. Of course, every school has a flag. Okay, Rockwood. All right. 12% of the students at Rockwood Junior High School speak Spanish. There are 36 students at the school who speak Spanish. All right. I'm not going to make the same mistake made with the other problem. Okay. Let's fill this out. 36 students is, well, the 36 students, is that the whole school? Is that the whole school or just part of the school? 36 students. Well, these 36 students speak Spanish, and according to the problem, 12% of the students at Rockwood Junior High School speak Spanish, so I'm going to assume that's the part then. So 36 students speak Spanish, but that's only 12%. Population. The question is, well, how many people were surveyed? Okay. How many students are in the school? Okay. That's what we don't know. How many kids in the school? All right. Here we go. We're making 2 equivalent ratios. We're trying to set it up. Again, you can simplify this, or you can see if there's a connection, if you can scale up or scale down. 12 times 3 is 36. Oh, okay. So 300 students were surveyed. Or a simple answer, just 300 students. Don't just write, you can't just write a number by itself. You have to say what that number means. Okay, what are we talking about? All right, last one, and then we'll call it quits. 25. The interior paint color, Melon Madness, is 30% yellow. Raul used 72 ounces of yellow paint to mix the last batch. How many ounces of Melon Madness did he make in the last batch? Okay. All right, for this one, I'm going to draw a little visual, a little bar of what I'm used to. Okay, this whole thing is Melon Madness paint. Okay. We know that to make this color of whatever Melon Madness is, we need 30% yellow. It means 30% of the, if you were to divide the paint into 100 parts, 30 parts out of the 100 would be yellow. That means the rest, 70%, would be other colors, whatever it is. Okay? Together, that would be 100%. How many ounces does it make? We don't know. So here's the deal. Let's think about this. The more yellow we use, the more we have to use of the other colors, right? This should make sense. According to this, if we use 72 ounces, of yellow, when we add that to whatever we used here, the answer should be more than this. This is only part of it, so the answer is going to be more than 72 ounces. You're going to have something more. All right, so let's look at this. Let's set it up. Part to whole, and for the percent, 100. All right, let's fill this out. We have 72 for the part. We don't know what once you add up all the paint, how many ounces we're going to have. Oh, you know what I forgot to add? I forgot to add the word. Talking about ounces. We don't know how much, when you add everything together, how many ounces we're going to have. We know this yellow is only part of the whole paint. It's only 30%. Okay, now see, this is what I'm talking about. We finally got to a problem where it's not obvious. You can't scale up. I mean, obviously you can, but what I'm saying is, in my head, I can't think of an answer that I can multiply by to get 72 from 30 to whatever. I'm sure there's some fraction or some decimal number I can use, but that's not the point. I want to make this easy for myself. So what I can do, remember, if you get stuck, I always fail, simplify one of the fractions. I can't simplify this, but I can simplify that. Okay, I can simplify it by after 10. That leaves me with 310. Okay, now some of you are still going to be like, but I still don't get it. Well, ladies and gentlemen, you're going to have to do a little math. If we're making groups of 3, how many groups of 3 do we need to, how many groups of 3 do we need to get to 72? Right? In other words, 3 times what number gives you 72? Again, we're scaling up. All right? And, you know, I said this before, if this bothers you, if this doesn't look right when you put the multiplication line, then switch the order. All right, you're like, oh, okay, I can see this now. Now that makes more sense to me. That's fine, whatever it takes. You have to do a little division, because it sounds like division. I have 72, I'm making groups of 3. How many groups of 3 can I make? That's a division problem. 3 times 2 is 6. 7 minus 6 is 1, bring down the 2. I can make 4 groups of 3 from 12. All right. 3 times 24 is 2. That means I'll do the same thing here. And I know I'm not going to do the math. I'll just tell you right now it's 240. You can do that. I'm pretty sure you can do that in your head or verify if you don't believe me. But let me remind you, the answer is not just 240. It's 240 ounces because the question is asking. Let me read it again to make sure. How many ounces of Melon Madness did he make in the last batch? He made 240 ounces. And that's the extra practice.